Alright class, this is the last lesson for Unit 2. It's called Solving Quadratic Inequalities. You can pause this screen if you want just to get all this stuff down. But basically there are 4 steps to doing this. First step is to get everything on one side and have it equal to 0, or I guess less than or greater than whatever the inequality is. Then solve for x on that side. Basically that will entail factoring or quadratic formula, although I believe most of the ones we're going to do today are factoring ones. Then plot your solutions on the number line. Remember open versus closed dots, and then we have to test the intervals to see which ones are true. Okay, so pause the video to write this stuff down, and then when you're done, you can unpause it and we will go on. So if we look at number 1, we have x squared minus 9 is less than 0. Okay, so the good news is this is already, everything's over to the left side. So the next step is, so step 1 is done. Next step is to factor this. Hopefully you guys realize this is a difference of squares. So we have this inequality. Then what you could do is just break these down and set them equal to 0. So you get x equals 3 and x equals negative 3. Just so I know what my values are, where my intercepts would be for this quadratic. Now I'm going to make a number line. And on that number line I'm putting negative 3 and 3. I'm putting an open circle because this is open, because it's not equal to, it's just less than. And hopefully you guys see that there are 3 spaces on the number line that are separated by these dots. We have to test to see if the statement's true in this region, over here, in the middle region, or in the far right region. So you have to pick x values that fall within the region. So if negative 3 is the boundary, I'm going to use x equals negative 4 for this one. If the boundary is between negative 3 and 3, a good one always to use is 0 if you can. And then something bigger than 3, I'll check 4. And now we test it in the original equation. So I'm going to put negative 4 in, square it, minus 9, and see if that's less than 0. So I get 16 minus 9 is less than 0. Which is what, 7? Which is not less than 0. This is a false statement, so this section is not part of the solution. I put 0 in. 0 minus 9 less than 0. Negative 9 less than 0. 0 squared, I should say. And sure enough, that is a true statement. So this, so far, is a solution. Over here, I square 4 again. It's just like the other one. You're going to get the same thing. 7 is less than 0, which is a false statement. So the only solution to this inequality is between negative 3 and 3. So if I write my solution in interval notation, I would say negative 3 to 3 with no brackets. Or this is it in inequality notation. Okay? Now real quick, I want to show you this. That was how you do it by testing it with algebra only. But think about if we drew a graph. X squared minus 9 goes through these and has a vertex down here. So if I graphed this quadratic, pretend that this is like the axes. Okay? All we're doing is saying, where does this quadratic go below the line 0? Which is this horizontal line. Well, sure enough, if you look at the graph, between these 2 dots, that's when the graph is below. So we were correct in finding that spot. But if you ever want to check, you should know if the thing's opening up or down. This is opening up, which means the bottom part is between here, where the top parts are going to be on the outsides. So you can look at it graphically as well. Okay, one more for today. And then we'll let you work on what you can work on. For ones like this, when you have no third number, you can pull out a GCF. So the first thing I'm going to do is pull out a GCF because everything's already on that one side. So when I pull an x out, I'm left with x and x plus 8, which means that x can be 0 and x can be negative 8. By the way, when I do these problems, these are going to be closed dots. Okay, closed dots. So, now I make my number line, and I'm going to put 0, and I'm going to put negative 8 there, and then I'm going to put 0 here. Here are my regions. I have to use x equals negative 9 for that one. By the way, this should be a closed dot because it hits there, and it hits here. So these are part of the solution in this one. Between 8 and 0, I'll do -1, and then I'll do 1. Can't use 0 or -8 because those are zeros. Alright, so we get -9 squared plus 8 times -9, greater than or equal to 0. So that's 81 minus 72, which is 9. It's greater than or equal to 0, which is a true statement. So this is part of our solution. Chances are, if this is with a quadratic, it's either going to be the middle piece or the two outside pieces. So if you check the outside piece over here, 1 squared plus 8 times 1, greater than or equal to 0, we get 9 is greater than or equal to 0, which again is true. If we check -1, you get -1 squared plus 8 times -1 is greater than or equal to 0. Well, this becomes a -8. So we get -7 is greater than or equal to 0, which is false. And sure enough, if I graphed my parabola, again, it would look something like this. Okay, that'd be my parabola. And again, it's asking this time, where does it go above the line? Well, it would be these outside branches is when the graph goes up forever and ever and ever. So sure enough, that is correct. So the answer here for interval notation would be -infinity up to -8, and we're including that. Union, we're including 0, and we're going off to infinity. That would be our interval notation. Again, you can say x is less than or equal to -8, and x is greater than or equal to 0 for inequality purposes, but I would prefer interval notation. Okay, that is how you solve quadratic inequalities. That is the last lesson for this chapter.